Hello, Mr. Aaron, Mr. Ryan, right? You remember the cache keyword, remember? Remember like when we defined a function, let's say Fibonacci number, right? Do you still remember what's Fibonacci number?
It's like what you add to, is in like a string of numbers, and when you start with 0 and 1, and you add those, the last two, the current digit and the last digit together. So like 0 plus 1 is 1, and then 1 plus 1 is 2, and then 1 plus 2 is 3.
Okay, so each number is the sum of the previous two terms, right? Yeah, okay, Fibonacci number. So we can implement the Fibonacci number. If n smaller than 0, actually it's bigger or equal than 0, right? If it's in 0 or 1, this is tuple. It means that if n is 0 or 1, then we return n. 0 or 1, okay? Otherwise, return fn minus 1 plus fn minus 2. This is recursion, right? And we need to assert n is bigger or equal than 0. Simple Fibonacci implementation, okay? The problem with this one is, as we said lots of times, it's very time consuming. Why? Because the recursion, look, if we want to calculate fn, right, we need to know fn minus 1 and fn minus 2. And if we want to know fn minus 1, we need to know fn minus 2 and fn minus 3. Okay, and this keeps going on. Okay, lots of the branches. Each branch has spawns into 2 branches. Have you seen the problem? Look, this is fn minus 2.
Okay.
And this is fn minus 2. What's wrong with this? When I calculate fn, I need this, right? Let's say I spend like hours figure out the value fn minus 2. Then I come back to this, okay? And then I need to solve fn minus 2 as well. So do I need to spend hours on this?
No.
No, that's right. Yeah, the first time I see this fn minus 2, I just cache it. So we put a cache here, right? We make it a top-down dynamic programming. So have you ever wondered what's this cache thing?
No.
Why it's, we just put the add cache and that's it. It just works.
So it's not exponential.
Yeah, no, but what's this? Have you thought about it? What's this? Why can we just put this on top? And then what does it mean? Actually, what does it mean here? It means that remember. It means that for every input, okay. Memorization. Look.
It has a brain. It means it has a memory brain.
Notebook. Okay. Hear me out. Okay. This fn, look, right? This function takes 1 parameter. So the first time if I say f2, right? I don't have this value. I don't see this value. I haven't calculated this f2. Okay. So let's say I spend 1 minute calculating f2. Okay, and after that, I remember I put it down in a hash map notebook. Okay, and next time you ask me for f2, instead of doing the actual calculation again, I can just look it up in a hash map, right? And I say, okay, here you are. I have this value because I calculated like 5 minutes ago. That makes sense. This is what cache is for. So basically, we are trying to memorize every fn. If the parameters, right, it could be 1 parameter, 2 parameter, or the parameter it could be many. This magic keyword, we just try to memorize the states of the f, right, depending on the input. So basically you memorize, in this case you memorize f0, f1 till fn, right? This is the number of total states that this n needs to be calculated for the Fibonacci number, right? For example, if we calculate f100, right? f100, how many states does this function need to be cached? If I call f100, 101 actually. 101 because it's from 0 to 100, right? Because look, if f100, so on the left is f99, on the right is f98. Okay, so look, this is 100, right? Now this is 99, this is 98, and this 99 is 98, 97. But remember, each value is only calculated once because we're using the cache, okay? So eventually it will be 100 till 0, okay? So that's 101 states. Make sense? Yeah? So this cache, okay, let's come back to this. This cache is called function decorator because look, we put it above this function. So this is called function decorator. What's decorator in English?
It means decorator basically means you personalize and customize your house. No, customize and customize something.
Customization. Okay, so it means to make it, to decorate, right? It's the word to decorate. It's the people, the person who decorates.
Yeah,
Okay,
but what does
it's the thing who decorates this function.
Then what does decorate mean?
Okay, yeah, good question. What does it mean?
The definition of a word can't have a word in it.
No, it's two different words: decorate and decoration. Decorator.
Yeah, but then what does decorate means?
Okay, so make
If a person who doesn't know what does decorate mean.
Good point. Okay, so try to guess the meaning.
It's just
I'm
different.
decorating
No, it
the
doesn't-
house.
No,
What does it mean?
No, it's still kind of the same word. It's just
Okay.
has a different it has the same root word.
Okay, so what does it mean actually? What does it mean? Can you
Ryan
give
just
me
said it.
Customize.
customize? Okay, that's a good one. Okay, so we are trying to decorate this function using this cache. Okay, so how can we implement this? So let me just write this. Okay, this cache thing. Okay, let me just write this. So actually, look, define cache is basically a function, right? Define a function, but it takes a parameter function. Once we have this, I can put this add on that, right? Remember this thing. Yeah?
Perimeter. It's pronounced perimeter, not like put the stress on the
Okay.
Rear, not pair. Rear.
Perimeter.
Yeah.
Better? Okay.
Yeah.
Good. Thank you. Okay, so this cache thing is from the existing library called LRU cache. Okay, from LRU, least recent used cache is one of the caching. What's caching? What's caching? When we talk about cache, what's cache? Not CA, not this. It's
We don't know.
CACHE. Cache to save for the future uses. Let me give you an example.
Okay.
We have a co-ops there, right?
Yeah.
Yeah. Let's say we are running out of sugars. Yeah.
About
Yeah, and then we are running out of sugars, right? So I need to go to the co-ops to buy sugars, and then come back and then find out. Okay, I'm running out of tomatoes, and then I need to go back to the co-ops to get it again, and then find out running out of bananas, tomatoes, apples. Every time I go there, it's a waste of trip. So instead of doing that, the first time you ask me for sugars, okay, and then realize, oh, you may need bananas, apples, etc. later. Then I go to co-ops to buy everything, and then come back. And the next time you ask me, okay, where is the apples? I give it to you. I don't go to the co-ops to get it from there because it takes more time. Instead, the kitchen, right? I put it in the kitchen. This is where the cache is. Okay,
it's not really like what.
right?
I don't think like necessary because how are you supposed to know if someone else is going to ask if he wants?
This is that's a different caching strategy,
if
but
you buy apples and we never ask for apples and then just rots away and then there's a waste of money.
you raised a very interesting point. Yes, that's the caching strategy. Okay, in this scenario, and the f function, right? This f function. Let's come back to this f100 again. f99, f98, and this is f98. Okay, look, I want to calculate f100. Let's say I always calculate the left first. I need this value, right? Recursively. Okay, f99, and I need this f97 and 98. Okay, so let's say I calculate these two, and then come back to this. Now I put these two values. I put these two in the cache, in the notebook, and then okay, later I found out I want this value. Right? Instead of going to co-op to get this value, I have it here.
Well, it isn't a very good example because this is a way different scenario.
But do you understand my point?
If you figure out all of them, like all of
You
them.
figure out all of them but never use some.
Yeah, like if you figure out all of them, which is a lot, and which is likely that you're probably not going to use one, so it's a waste of time.
True. Yeah, true. Okay, that's one scenario. Yes, because you are doing the work for the things that you may not need, right?
Yeah.
Yeah. Okay. That's one scenario of caching. This is called proactive caching. On the other hand, this is called reactive caching. Reactive caching is that you ask me for this. I go to the thing. I check the cache first to see if I have the thing you need. If I don't have it, I go to the stuff. But before I give it the result to you, I put the stuff in the caching, which is close. I can just get it. So next time somebody, not you, somebody like Ryan, you ask me for apples, and I can give it to you.
It's probably.
Do you get it? Okay, so this scenario is very good. Okay.
No, it's probably rotten.
That's true.
Look, okay, let's change it to pencil. Okay, for example, Eric, you ask me, you come to daddy, say, okay, can I get a pencil? Okay, I don't have it. I checked by my desk, which is the cash. I don't have it in my cash, in my table. What do? I go to Co-op to buy the pencil.
I'm not sure they sell pencils.
Okay, come on, please. I go to Co-op to buy the pencil. I buy, instead of buying one pencil for you, I buy a bunch of pencils. I buy 10, for example. And I give you one to you. I put the 9 here. Right? But for the caching, it's not like the number, but this is just for simplicity, okay? And next time, okay, Ryan, you come to me. Can I get a pencil? I check the table. I have it. I give you one. Okay, let's say this is caching.
I don't want to ask you for a pencil.
Okay, together. Okay, let's drop it. Okay, you know, one typical example is that the bbc.co.uk, right? The website on the homepage of BBC, it has this news, right? Which doesn't update every minute. It only updates once per day, right? So let's say like 1 million users coming to visit, type bbc.co.uk. The server don't need to generate a list of news for every time, right? Instead, it has a static caching website, caching page. So this user comes to visit bbc.co.uk. I give you this prepared list. You come to me, I give you the same. But the next day, I update the cache, the list of the news, right? This is caching, okay? So coming back to this, the cache, define cache, okay? This is the cache. And then define the wrapper. Okay, so now I just need to call this function.
Did you explain what wrapper is?
I explain, okay? Okay, define a wrapper n, function n, and then return wrapper, that's it. This is the cache, but we haven't implemented the caching yet. So this is basically of the structure of the function decorator. It returns a wrapper, which is the local function, return that. So you call this, which has the parameter, right? Come on here. Yeah.
Which part of the code?
This part.
Is it just a red part?
Yeah, for the cache, this is how we defined it, but not quite yet. This is the basic structure of the function decorator.
So the one in the big red box.
And this. Okay, so what does it mean? It means that we return this. Sorry?
Is that the code?
Yes.
What's the other part?
I haven't implemented it yet because we haven't implemented the logic. So look, this is takes the parameter wrapper function. This is original function, which is this f, right? F function, because we put the cache above this function. So this function parameter is this. Here we call it with the single parameter n. We need a notebook, the notebook. So we have a notebook here. Notebook is a dictionary, okay? Dictionary.
Where's your column after define
Look,
wrapper n?
if
Hey, Dad.
n
No, it's
in
not
notebook.
the black.
Sorry?
It says define cache fancy.
I thought how about to define wrapper?
No.
Okay, so
no,
let me finish.
It's not the red part. I don't know why, but
If
they just started writing in red.
Dad,
n
why
in
did you start writing in red?
return
Why?
notebook n. Wait, let me
Maybe the pen wasn't
finish.
working.
Notebook n equals function n,
Yeah,
and
maybe
then
he found a
return
new one.
notebook n.
Oh, why
Okay.
didn't you stick with
Okay.
red?
So this is
I don't
how we
know.
define it.
Maybe this
Sorry.
one is better.
So this is how we define a cache
complaining
function
about-
decorator. So how does it work? Look here. Look, notebook. Right. This is a dictionary storing the key value pairs. This is the notebook. Right. So wrapper. Right. What's wrapper? Wrapper is to wrap things. Right. Like your presents. We use the wrappers. Right. So wrapping this function. So we check n parameter n.
It should
If
be
we
equal to-
seen it, if we have calculated this, if we have found this in a notebook, then we just simply return it. We don't need to calculate it again. Otherwise, we call the function which is here, the function decorator. We call the functions to get the value, and we put it in the notebook, right? And then we return it, right? That's it. Does it make sense? But look, the problem with this is that it's only it's for one parameter, right? But the thing is, it's not for the general cases, because the function could be having 2 parameters. So So this is the function decorator for the cache, okay? So we return a wrapper. Because this function decorator return the wrapper. Why? Because this wrapper is basically wrapping the original function here, right? But it takes a parameter n. And we check if n has been calculated when we pass f100, right? N is 100. We check if we have calculated f100. If we have calculated, then we just look it up in the dictionary. Otherwise, we call the function, original function, to calculate the value and put it in the dictionary, right? In a cache, in a notebook for the next time. Next time, if you want the f100, then I can get it, right? The only one problem with this is that because look, this is hard-coded, the only one parameter, okay? But in Python, we can use this star args and star KWARGS. This is this means that no matter how many parameters you put here, I can get it. This is a dictionary, a key value object parameters. Okay, this one is the traditional, the classic parameters. Okay, but we don't need to worry about that at the moment. Okay, this is a little bit advanced topic. Do you understand this now?
Yeah.
Kind of idea, right?
Yeah.
Why do we need to put a cache over the functions? Can you explain to me why? What's cache?
Remembering.
Why do we need to remember it?
Otherwise, because then we're wasting time.
Yeah, do you understand the co-op example, right? Yeah? Kind of, yeah? Yeah. For example, you do the math. You do your math paper, right? You do a math challenge, math paper. Sometimes you calculate the intermediate result like F50, okay? But you are not using it. F50 is not the final answer. You just put it. You just write it down on a piece of paper.
Do you mean math 55?
Yeah, something like. Okay, wait.
Math 55.
F50, for example, like the result, you just put it down on your piece of paper, and then you keep working out until you need it, and you go get it, right? You're not just doing the calculation at the time, right?
That's the thing.
Yeah?
That's the thing. I don't think cache is very useful in the scenario situation you're talking about, because like in the math paper, it's like when you want to work something out, you just write it down. And so it's kind of like you going to the co-op to buy something when we just ask.
Yeah, but you may not need it immediately. That's the thing.
No, you're not understanding.
Okay.
I'm saying that like instead of doing it all and buying all of the stuff, you only go to the co-ops when someone asks. Like if I say I want something, and then
Hey Dad,
You
you
go
know
to
how
the
you say,
co-ops.
you know how you say you're remembering things so you don't waste time?
Yeah.
Well, in the co-ops, if you buy one pencil, and then Eric wants one pencil, but you bought 10 pencils, you're not remembering anything.
Yeah, that's not a proper example, but the idea is the same thing. Okay, the idea is the same thing, right? Because it's in computers. When I give you that, I don't lose the quantity. Right? I don't lose the quantity. Okay, but in real life,
you know how you say like for the co-op example, you know how you say like it's best to like buy it all at once instead of like going back and forth, only when we need it.
yes.
That's kind of like in the math paper. It's just like you only do your work. You only like write on a piece of paper to do your workings when you need it. Yeah, like if you're trying to find a question out, you just write it because you kind of need it, and sometimes you don't. And that's kind of like in the co-op example, like how you just go back and forth only when you need it.
Yeah, not quite the same, but similar.
No, that's what 2 examples you just gave us.
Okay, but you understand, caching, yeah? The difference between the co-op and the computer example is that in computer science, when I give you the result, like F50, you need it. I can give you as many times as you want. You ask me F50, I give you the answer. You ask me F50, I give you the answer. Nothing changed here. But in real life, the co-op, the apples things, I give you one, the quantity minus one, right? Yeah, that's the difference. Okay, but you get the idea, okay?
That's not a good example.
Okay, think about the example and let me know next time, okay? Yeah, let me know next time, okay? Okay, that's it for today. Bye bye. Bye bye. Bye bye.